right, so here we are looking at graphs. Reading a graph is an important part of economics. We convey a lot of information about the relationships we're talking about graphically. So that is one of the key skills that you will pick up from this class that you can use in other business classes. Even if you go further with economics, being able to read a graph is an important business skill. A lot of data will be presented to you in that format. And so what I want to focus on right now is the intuitive understanding of reading a graph, not just the mechanics. At some point in time, I'm sure you've been taught in one math class or another the various components of slope and whatnot. And while I review it, what I really want to focus on more is the understanding, the idea that when you look at the graph, that you understand that there's meaning behind it. So let's take a look real quick at a graph. Okay, so we see here a nice grid format. In math class, the vertical line would be your y-axis going up this way. This horizontal one would have been known as your x-axis. In economics, the y-axis, the vertical axis, is where we put prices, and the x-axis, the horizontal one, is where we put quantity. And so what we're talking about then with our demand and supply is two different curves that show somebody's relationship between price and quantity. So we'll see then with a demand curve, it'll look something like this. And one of the things we're going to want to get from this graph review here is the intuitive understanding of what this line is telling us. Yes, on one level, we do see that we see a line that starts here and it goes down this direction. But why does it do that? What does it mean that it does that? And what it means then is that the price, when it's high, is associated with a quantity that is relatively small. And as prices fall to something relatively low, it'll be associated with a quantity that is high. So when prices are high, quantity is low. When price is low, quantity is high. So they're moving in opposite directions. And so that's what we want to understand intuitively when we look at a line such as this. If these two variables, whether it's price and quantity or any other things, that when you see a line that's relating, that is describing, pictorially describing the relationship between price and quantity, right here, price and quantity, it's telling us that when one goes up, the other goes down. All right, so here we see our supply curve. And what we see here is that when the price is at $2, we got a quantity supplied of 2. When the price is at $5, we can see that we would have a quantity supplied of 5. So why do we have this? What's going on here? Well, first of all, we have to think about what a supply curve is. And a supply curve is telling you what quantity producers are willing to buy at different prices. So we have then a case where the producer, if the price that is in the market is the $2, that's a pretty low price. And they're not going to make a lot of money and may not even be able to afford to sell it. So what's going to happen is out of all the firms in the industry, only 2 items will actually be produced and sold. Now, if the price goes up to 5, there's more money for each item you sell. It allows producers those who have higher costs, for example, can afford to produce. And so at $5 then, they're willing to produce 5. Go on up to $8, and at that high price, they're willing to supply as many as 8. So we see this positive relationship with the supply curve. We know it's a positive relationship because as the price goes up, the quantity supplied goes up. That's the mathematical understanding. But what we really get is that producers are willing to supply more to actually increase their quantity as price goes up. And that seems like a pretty intuitive concept. Now, if we go on over to the demand curve and look at it in a similar way, what we're going to see then is now we have to think like consumers. Do you like high prices? Do you like low prices? Personally, I like it when prices are low. And so we see then when the price is high up at $8, the quantity demanded will only be 2. But with the price falling all the way down to $2, the quantity supplied will be 6. So as prices come down, quantity demanded goes up. And all that means is that you like to buy more when the price is lower. And so we see then that there's the mathematical relationship, which we'll look at just in a sec, at slope, but there's also the understanding that this line is telling a story. This negative slope line, the demand curve, is telling us that consumers like to buy more when prices are lower. So now we can look at the actual calculation of the slope. Okay, here we see our demand curve showing us the beginning of the calculation of the slope. You might have learned that the phrase rise over run, that was the way I learned it, which means that you are tracking in the rise part the direction on this axis, and the run part is over here. So in the case of this picture here, you're rising, or actually in this case you're rising is a fall, this direction, and then you're running, falling, running, falling, running. I guess we could try to do running, rise, running, rise, running, rise. And so that's what you're looking at. You're looking then, this is just the way I learned it, was rise over run. But in our case here, this would be the change. The little triangle is a delta, and it means change. Change in price over change in quantity. So we can see then that the change in price is this $5 to $3. So if we move from this point here, or this point here to this point here, then we're going to see a fall in the price of 5 to 3. So that would be, in the numerator, 5 minus 3. And then in the denominator, the run part is moving from 4 at this point to 6, or what I guess I'm calling 6. It's close to 6 at this point. And so then the denominator would be the 4 minus 6. And what you're going to see with the demand curve is one of these two will be a positive and one of these two will be a negative. So we see 5 minus 3, of course, is a positive 2. 4 minus 6 is a negative 2. And that leaves us with a slope of negative 1. What does that mean? It means that every time the price goes up $1, the quantity demanded goes down $1. You're getting this one-to-one relationship from this meaning of the slope, and the negative is telling you that they're moving in opposite directions. All right then, so starting again with a demand curve, what we want to talk about now is what we've looked at so far, let's say that, is the relationship of price and quantity demanded. And so clearly then, if the price was $8, and the quantity demanded is 2, and we have a change in the price for some reason. Let's say the price drops down to $5. Then what we're going to see is this movement along the demand curve. That's the language you'll hear me use. The change in price causes a movement along the demand curve to the new quantity demanded. So all we're saying here at this point is if something in the market has changed, so that the old price was 8 and the new price is 5, nothing has changed the actual relationship of the consumers, how many they want to buy at different prices. All that's changed is the price. So you simply move along the existing demand curve to locate what the new quantity will be. So when you're looking at one of these two variables changing, price or quantity demanded, then nothing has to change for the demand curve. You just move along it. So you're basically just answering a question. You can imagine you had a table with all the prices listed and all the quantity demandeds listed, and you're just saying, okay, we were here, and now the price has fallen, so now we're here. So you're just moving along the existing demand curve. Why am I making such a big deal of this? Because we're not limited to just the relationship. We're not limited to just illustrating a change in price. We can actually illustrate when a third variable changes. But a third variable is not on this graph, and we don't want to draw 3D. So how do we do that? How can we show the impact of a third variable? And that's what we're going to look at next. Okay, so what we see here is our original demand curve. And for some reason, we've got a second one drawn on here. What we're saying in this picture is here is the original consumer's relationship between price and quantity demanded. And at any time a demand curve is drawn, it's based on all other variables being at a certain level. Anything that impacts the consumer's demand for this product is assumed at a certain level. When one of these factors that is relevant to demand changes, the whole demand curve will shift. What are some of the factors? We'll learn them in detail in Chapter 3, but you can imagine something like income would be important. The reason the consumers only want 2 of this item when it's $8 is in part dependent on how much money they have to spend in total. So if they had more income, if they were willing to buy 2 at $8, now just having more money means they can buy more of everything. $8 could now be associated with a quantity of 4. And then that's not true just at that price, it's true at every price. So look at $5 used to be associated with 4 and now associated with 6. And so what we're seeing is that every price is now associated with a new quantity demanded. And this is where you get the shift in the demand curve. So the whole demand has increased. And so let me emphasize the language here. On the previous graph, when the price was changing, we moved up and down along the demand curve, but the demand curve did not change. And so what you would say is price goes up, quantity demanded goes down. Price goes down, quantity demanded goes up. And that's telling us that on a picture, you would just move along a demand curve. Here on this slide, what we're seeing is the entire demand has changed. This is a picture of a demand increasing. And that's telling us that there's some third factor, in my example it was income, that has affected the consumer's desire for total quantity demanded at each price. So this is how you illustrate the impact of a third factor. And like I said, in Chapter 3, when we get to what shifts the demand curve, what shifts the supply curve, we'll learn all those different outside factors. All right, the last thing I want to cover is actually a formula, not a graph, and it's the percentage change formula. It's something that's very useful in economics. We'll at least see it with elasticity, but you'll see it in all sorts of areas in business. And it's just a good statistic to be able to explain what is happening maybe in a series of numbers, how things are changing over time. All right, so for example, let's say you had some GDP figures for some various years here that I'll write down for us. These are the figures for the United States for these years written in trillions, which is basically a number beyond our ability to understand. You'll learn more about GDP in the macro section, but roughly it is the economic size of our economy, the production and consumption of our economy. So we're talking about almost 15 trillion in 2010, just over 16 trillion in 2012, and almost to 17 in 2013. These are giant numbers. It's hard to understand. All we can definitely see for sure is that they're growing. But, you know, how significant is, what would this be, 1.8 trillion growth from 2010 to 2013? How significant is this little bit here of 60.6 trillion this last year? The percentage change formula helps us answer that question. So we're not looking at the absolute actual numbers like we did here. We can just look at how they're changing over time without worrying about the size of the numbers. And so this is the formula we're going to use. Percentage change, the delta equals change, is simply looking at the numerator is what most people do when they forget this formula. They just look at the difference between those two, and that's what I was just sort of eyeballing there. What is the change in these numbers? But that doesn't give you any real understanding of is that a big change or a small change unless you compare it to something. And so when you divide it by the value in the first period, you're saying, okay, here's the difference between these two. Look at 2010, 2012. We see that's a little over $1 trillion in change, but is $1 trillion big? Well, I don't know. Let's compare it to what it was originally, which is the 14.97 trillion. So, for example, then, using these numbers, you would get, let's see here, between 2013 and 2010, you would have, in the numerator, 16.77 minus the 14.97. You would divide it by what it was in originally, because what this is telling you is how much the number has changed. Is that a big change compared to what it was originally? And then you always do times 100 to get it to be a nice little percent. And that would work out to 14.97 So it's been a 15% increase in GDP from 2010 to 2013. And so that's helpful because if you wanted to look maybe at different time periods, it doesn't help to say, ooh, our GDP grew by over $1 trillion. If you look back 10, 15, 20 years where the trillion is a significant percentage, that's not very comparable. But when you can say it has grown 15% over these number of years, that's something that you can then look at over time. Also, of course, looking at different countries and how they've changed. So that was the percentage change from 2010 to 2013. If you look at the change between 2012 and 2013, I'll let you work that one yourself, and hopefully you will find out that it's 3.77%. All right, that will conclude the math review section of the class. If you want to do more review, you can look to your book. You can look to My Econ Lab. They have a lot of practice questions there. And you can also check with me or other students in the class if you have any other questions.